Hello, good morning. Sorry I couldn't be here today. I'm actually around, I'm in the building. I just had to be at a meeting during our class time. I will be around after school if you want to come by to get any help, or if you want to come by to reassess either of those things, feel free to do it. Hopefully by now the sub has already passed out the notes and the classwork and the homework. It's all in one document. You should have those lecture notes in front of you. You're going to be filling things along with me as I talk. So at the top on the first page, main concept. That should line up right with what we have right here. Main concept. Evaluating functions, f of x. That's what we want to write there in our main concept so we know what we're talking about here today. Now, this video goes a little fast, so you're going to have to excuse me beforehand if I'm hitting play and pause because I'm recording a video of a video. I know it's like Video Inception or something, if any of you are familiar with that movie. So let's go on here. So these two things right here, take a look at them, decide, do you think these are functions or not? Think back to what we know about functions. A function, every input has only a single output. So we look down here at this one, 2. Does this have one output? Yep. -3. Does this have one output? Yep. 5. Does this have one output? Yep. 0 as well only has one output. All of our inputs in both of these only have a single output. So we have two functions. Now, when we have several functions, we need to name them so we can tell them apart. This is one of the problems that we have with saying everything is just y equals, because we get the same names for multiple different functions. So instead of using that, we use things like f, g, h, things like that, so that we can tell our functions apart in different problems. So you should be copying this down into the box that says function names. It already has these two functions at the top drawn for you. You should be writing down, oh, we want to write, maybe we would call that one f and that one g. So you could put an f under the one and a g under the other one and write about why we would call them different names, because it helps us to tell them apart in problems. All right, going on. Function notation here. This is our next box. We got f of x. The x right there is our input, and that is what we're going to put into our function. We've talked about a function as a machine. We want to put something in, we want it to spit something out. F of x, the x there, is what we're inputting. So when I say f of 3, I mean that I want 3 to be the input. F of x means we don't know our input yet. Right now it's some variable, x. And then the whole thing, f of x, once the function has done its work, f of x, once it's taken x and done whatever function stuff it's going to do to it, that is the output. So here's some words we can write down. The This means what is the output of the function f? What do we get? Output. Remember, we're using the words input and output a lot and thinking about this as a machine. What is the output of the function f when the input is x? And this is similar. This is what you've seen always before. We said y equals, but now we're going to be using function notation a lot more. It's just a lot more descriptive, and I think makes a lot more sense. Now, this next part down here is hard for me to get paused at exactly the right time, so I'm going to go real slow. All right, word of caution. This f of x here, f parentheses x, it does not mean f times x. F by itself is nothing. F of x. F is a function. It needs inputs. By itself, it is meaningless. It is f of x, not f times x. Write that down in that caution box. Write it down right now. Does not mean f times x. And we can say that y equals f of x. We can think of it as y, or the outputs, just like we've always thought of y and x. This is a new way to talk about that y value, or that output value. All right, moving right along. All right, evaluating a function. Evaluating a function is the process that when we're given an input value, we want to find its matching output value. So for instance, if I wanted to, let's see what we have on here. I wanted to find f of -3. So first of all, I've got to figure out which of these functions am I talking about. I've got two functions, g and f. Well, here's f, and f of -3. -3 is an input value, so I look here, -3 as an input value. F of -3 That's the function value. When we plug in -3, it takes us to -9. So you can write that down. You should have a spot right there on your chart. We're still on the bottom of page 1 where you can put f of -3. All right, g of 5. Let's look at that. Now we're talking about the other function, g of 5. Now this one is shown in tabular format. So g of 5, is that an input value or an output value here? It's an input value. We look in our x column, our inputs, and we see 5 here. And then we're looking for the corresponding output over here in our y column. Remember, g of 5 or g of x and y, we can think of those things as being the same here. So g of 5 is 12. F of 5, same thing. Go back to f, input of 5, output of 1. Hopefully you're getting the picture by now. G of -7, the next one right there. Look at your table. G of -7 equals, right there, -7 input, output of -6. Now, finally, we're going to get into some addition, subtraction, and multiplication of functions and their values. So we've got f of 0 plus g of 1. So we find f of 0 from our chart over here, that's 2. We find g of 1 from our chart over here, that's 6. And we take those two values and we add them together. Oh, let me go back here real quick. We add those two together to get the f of 0 plus g of 1 is 8. All right, going on now. That should be fairly straightforward and make sense. All we're doing is plugging things in, finding an input, and matching an output. All right, now we can also do this graphically, so go ahead and turn to the next page of your notes. We have two functions here again. We have them named. F of x, that's this linear function, and then g of x, that's this parabolic function right here. Now, f of 0, what does that mean? That means that we have an input of 0. F of x is right here, input of 0. Now, where are the inputs on a graph? The inputs on a graph are here along the x-axis. These are the inputs. So there's 0 along the x-axis, and when I have an input of 0, what is the output of f? I have to look up, follow my mouse here, look up and hit here. Where do we hit f? We hit f at an output of 2. So f of 0 there is, there we go, a little animation, is 2. I'm going to go back and play that. That animation was so cool, so you can see it again. So if you didn't catch that the first time, watch this here real quick. We want to, oh, maybe I'll go back a little more. All right, so we have f of 0. There, right there is the input of 0, that red line. And then we're going to go up till we hit f of x to get 2. Now g of 3, same thing. So we're going to go over here to 3. And now we're looking on g of x, this parabola. What's the output of the parabola at when x is 3? Well, there's our line at 3. Those are the inputs we're looking at. And where does that hit g of x? Well, right there at 0, right on that point. So g of 3 is 0. All right, next one, f of -3. So there is our input of -3 over here on the x-axis. Go over to -3. And then we're going to want to go up this line and figure out when the input is -3, where is this function f at? So there's our little dot traveling up there, and we hit that function at an output value right there, an output value of 4. So f of -3 is 4. And g of 2, another example, there's our input value of 2. Now this is the first one we've had to look. We're not going up this time. When we input 2, our output is actually going to be below, and we go down and we see that the output is -1. And then, now another example, I told you we're going to be taking things and adding and subtracting, multiplying and dividing. F of 6 times g of 4. So we've got to figure out both of those values first. So we go over there. Here's how we're going to figure out f of 6. We go to the input value of 6. We see that we need to go down there. We get -2. Then we need to figure out g of 4. So we do this again. G of 4 is 3. So together we're going to have -2 times 3. So, oh, let me go back real quick. Sorry about that. So f of 6 times g of 4. It's so hard to get this timing exactly right. So f of 6 times g of 4 is -6 right there. F of 6 gave us -2. G of 4 gave us 3. So when we multiply those two output values together, f of 6 is an output, g of 4 is an output, we're multiplying them together, we get -6. All right, going on to the next section. Evaluating functions when we're given the function. This should be fairly straightforward. F of 2. Compare this up here to f of x. We have 2 in place of x, so all we're doing is plugging in 2 for x. So it's now 3 times 2 plus 5. Real straightforward. We get 11. Next one, plug in -4. -4 goes in place of x. So we've got 3 times -4 plus 5. So that's -12 plus 5 gives us -7. Next, g of 3. So this is where things we need to be very careful that we're plugging in this value, whatever we put in for x. Look, we had g of x, that is our function. Now it is g of 3 we are evaluating. The 3 needs to go in place of every x in that function. So the 3 goes in for the x right here, so the 3 needs to be squared. The 3 goes in for the x over here, so it needs to be 2 times 3. So we've got 3 squared plus 2 times 3 minus 1. So 3 squared is 9, 2 times 3 is 6. We subtract 1, we're up to 14. Finally, g of -6. Now, here's where it's good if we are careful, because we're plugging in -6 into each of those places. -6, oh, gotta hit play. -6 squared plus 2 times -6 minus 1. So what is -6 squared? What does it mean to square something? It means to multiply it by itself. So -6 squared is positive 36, because it's -6 times -6. So we got positive 36 minus 12, because that's 2 times -6, minus 1 there, and we get 23. We need to be very careful when we're evaluating functions that we're plugging in the value everywhere that we find it, and that we're plugging it in specifically for x. Anything that happens to x in the function has to happen to the value when we plug it in. If the x is squared, the value that we plug in must be squared. If the value is divided by some number, then when we plug it in, the value needs to be divided by some number. So we need to make sure that we're paying special attention to do that the whole time. All right, now the next section is classwork. What I want you to do is to go ahead and work on that classwork. You are free to work on it with a partner, and I want you to try to get through the first page right now. And once you are done through the first page, I want you to come up, and the sub is going to have an answer key, and they're going to let you check your answers on the first page. If everything's good, thumbs up, let's go ahead and keep going on. You should be able to get through the classwork in class, and then hopefully you can take some of the homework home and do that tonight. So try to get through the classwork. Check your first page if you get through it. If you get through the second page, then you can come up and check that with the sub as well. And then for the homework, I'm going to go ahead and post the answer key to that on my website. If you have any questions, once again, feel free to come by after school, refer back to your notes, all of those things, and I will be around after school, and I will be back tomorrow. Have a good day, guys.